Nirmal Shah on the behalf of Tinkerers Lab. Welcome you all to the second live session on Arduino. So before proceeding further, if you have any doubts related to the resources which we have shared or the last session, you can ask in the chat or you can on your video and ask. Okay, so now further proceeding in this session. So before starting the second session, we are going to have a short recap for you of the previous session so that you can recall it. Okay. So we are going to have a small recap of the different types of pins which were explained by Veena in the previous session, and also we are going to look at two different types of sensors, that is the servo motors and the ultrasonic sensors. So we are going to discuss on the different types of pins on the Arduino. So I'm going to give you a small brief summary of which pins are generally most commonly used, and you should have a basic knowledge about it. So Arduino Uno has 14 digital input or output pins. So as you can see here, from 0 to 13, these are the digital pins, out of which 6 can be used as PWM pins. So as you can see in the diagram, all these pins which have a tilde sign in front of them, they are specially designed pins which are specially used for the PWM signals. And the another are the 6 analog input pins. So here, as you can see, starts from A0 to A5 and it is used as an input pin. Then we have at Mega 328P. So this black thing here, as you can see, this is the brain of the Arduino, and this is the microprocessor that works behind all your projects. Next are the digital pins. So this from 0 to 13, these are the digital pins and which have only two values, 0 or low or 0 volts, or 1 or high or 5 volts. And these are used for output or input pins. So the next one are the analog pins. So this from A0 to A5 are the analog pins and they take input in the form of analog signals and returns the value between 0 and 1023. So it has an internal ADC, that is analog to digital converter, and which is made up of 10 bits. Hence it has 2 raised to 10 resolutions or 1024 values. Hence it has a range between 0 and 1023. The next thing I'm going to discuss are the PWM pins. So PWM or the pulse width modulation is a technique for getting analog results with the help of digital means. So what happens is that we use a command analog write to use the PWM pins and give a voltage which is between 0 and 5 volts. So it has a scale of 0 to 255, or you can say 256 values, or 2 raised to 8 resolution, or it is made up of 8 bits. So if you write analog write 255, it means that you are requesting 100% duty cycle. So during one cycle duration, as you can see, that is between two green lines, it remains high for the whole time. That's why on averaging out, we get a 5 volts continuously. Similarly, if we write analog write 0, so we are requesting 0% duty cycle. Hence, during one interval, gives us a value of 0 volts, and on averaging we get 0 volts. But if you write analog write 127, which is approximately the half of 255, hence in one duration of one time cycle, we are requesting 50% duty cycle. It means that it remains high for half of the time in one duration cycle and low for half of the time. So on averaging out, we get a constant voltage of 2.5 volts. So similarly here, as you can see, for analog write 191, so we are requesting 75% of duty cycle. So what does it mean? That for the 3/4 of the time in one duration, in one time cycle, we are requesting a high output for 3/4 of the time and low for 1/4 of the time. So on averaging out in one duration, so we are getting a voltage of 3.75 volts. I hope that it's clear. So, today I'm going to talk to you about two basic sensors which we all would have used in our previous competitions like accelerate or RC plane competition. So the first sensor is the servo motors. So servo motors are DC motors that allow for precise control of angular position. So the one which I'm going to explain to you today are the ones which are most commonly used, and that is the SG90 servos, and which only rotate from 0 to 180 degrees. So first, I'm going to explain to you about the wiring of the servo motors. As you can see, it requires three connections. So the brown or the black one is connected to the ground, the red one is connected to the power, and the yellow one is the signal wire. So we need to give the signal through this wire to the servos. So now I'm going to explain to you regarding the working of the servo motors. So servo motors, they have motor driver and feedback circuit that make sure that the servo arm reaches the desired position. So they receive a square wave which is very much similar to PWM cycle in the signal, as you can see from here to here. It lasts for 20 milliseconds, and for the most of the time, the value is low. So, if the pulse width, as you can see here, if it's 1 millisecond, then the servo will rotate at 0 degrees, and if the pulse width is 2 milliseconds, then it will rotate 180 degrees. So you can map with the linearity that if we give a pulse width of 1.5 milliseconds, then it would rotate about 90 degrees. So this is a very good and reliable method, and this is the graph which would make you easy to understand. So now I'm going to go in Tinkercad and explain to you how to write the code. So now I'm going to introduce an Arduino. Then I'm going to introduce a micro servo. So now, first we would attach this pin to the ground. Then this pin to the power over VCC. Give it a 5-volt power supply. Change the color to red. And this is the signal pin. So we have to attach it to the digital pin. So you can attach it to any pin from 0 to 13. And it's going to be attached to the 9th pin. So now we will write the code for it. So I am going to write it in text, because in actual in Arduino IDE we all write it in text. to use servo in your circuit, you need to include a library, and the syntax for it is very much similar to what we used to include a library in CS 101. So we would write hash include, and the library is servo. So H. Then we need to create a object of the servo. So, so the name of the object that I am going to create is S. Then in void setup, we need to specify where the signal wire is attached to which pin of the Arduino. So here I have taken the ninth pin. So the command for it is s dot attach 9. So now our aim is to rotate the servo from 0 to 180 degrees and from 180 degrees to 0 back and forth. So in loop, now I'm going to create a variable which is of has a data type of int, and the variable name is pos for position. So now I am going to use a for loop which has an initial value of 0 and which goes till 180 degrees with an increment of 1 degree. So now we need to give the command to the servo that it has to rotate at cos angle. So the command for it is s dot right cos, and then we are going to give a delay of 10 milliseconds. Then again we need to rotate it back from 180 degrees to 0. For that, again we would use a for loop, but this time we are going to start from 180 degrees. Then we have to keep it greater than equal to 0, and then we are going to decrement it by one angle. So here again I am going to write s right, and then I'm again going to give a delay of 10 milliseconds. So this is the code. So now let's start make it run. So now as you can see, the servo starts to rotate from 0 degrees to 180 degrees back and forth. So now I have prepared a small live demo for you all guys. I would like to show it to you. Just wait for 2 minutes. Okay, so is everybody able to see?
Yes.
Okay. So
Yes.
now, this is a servo. That is the SG91 servo. I talked to you about this are the three wires. So the yellow one is for the signal wire. The red one is for the power wire, and the brown one is for the ground. So I have attached it to the Arduino, and now I'm going to connect it. So now I am going to run the code. I am going to upload this in the Arduino. So now, as you can see, the servo starts to rotate from 0 to 180 degrees, from 180 degrees to 0, back and forth. This was the demo. So moving on. Okay, so the next sensor that I'm going to tell you is the ultrasonic sensor. So ultrasonic sensors work on the principle of reflection of sound waves from a distant object. So as you can see that it converts the electrical energy into acoustic waves and vice versa. So this is how an ultrasonic sensor HCSR04 looks like. So it has four pins. So the first pin is the VCC pin. So it powers the sensor. This is typically with plus 5 volts. Then this is the ground pin. So this is connected to the ground of the system. The next pin is the trigger pin. So the trigger pin is an output pin. So this is kept high for 10 microseconds to initialize the measurement by sending ultrasonic waves. And this is the echo pin, or also known as echo pin. So this is an input pin, and this pin goes high for the period of time which will be equal to the time taken for the ultrasonic waves to return back to the sensor. So to get more clarity, I'm going to explain to you its working. So here, this is the signal diagram. So to begin measuring the distance, first the microcontroller, that is our Arduino, sends a trigger signal to the ultrasonic sensor. So the duty cycle of the trigger signal, as you can see, it's 10 microseconds. So when triggered, the ultrasonic sensors generate 8 acoustic bursts of ultrasonic waves, which have a frequency of 40 kilohertz. So as you can see from this part, this blue lines, as you can see, this is the ultrasonic waves. So after hitting the object, it reflects back the ultrasonic waves. And at the same time, as you can see, the echo pin gets high when the eighth ultrasonic wave burst is removed from the trigger pin. So as soon as the reflected signal is received back, as you can see, it's receiving back, the timer stops. And as you can see, the echo pin goes low. So the output of the ultrasonic sensor is a high pulse with the same duration as the time difference between the transmitted ultrasonic burst and the received echo signal. So now I am going to explain to you this concept in the Tinkercad. So now I am going to take an Arduino. Then me take it with a breadboard. So here, as you know that in the previous session, we know that this is the entire negative ray which is connected to the ground, and this is the entire positive ray which is connected to the plus 5 volts or VCC. So now we are going to take an ultrasonic sensor. This is the distance sensor. We attach it here. So now I'm going to connect the VCC, 5 volts, then ground, then let me connect the trigger pin, 10th pin, and the echo pin, 9th pin. So now let us write the code for it. Now I'm going to write it in text. So first, as we want to see our distance, so first we need to initialize our serial monitor. So for that, I'm going to write the command. And then you know that from this diagram, we first will make our trigger pin low for 10 microseconds. Digital, right? So our trigger pin is connected to the 10th pin, right? 10, then we would give a delay of 10 microseconds. So the command is delay microseconds. I'm going to input 10. So now we would make our trigger pin high, and then we would keep it high for 10 microseconds and then make it low. Then we would give a delay of 10 microseconds. And then we would make it low. So during this duration, so we need to measure the duration or the time interval for which the echo pin was high. So it is used. So there is a command known as pulse which does our job. So I would save the time interval in a variable time, and we have to use the command pulse in. So it has a two input. So first one is the pin number. So we have attached our echo to the 9th pin. I'm going to write 9, and for what duration, whether the pin was low or whether the pin was high. So we need to measure the time duration for which the echo pin was high. I would write here high, and then for measuring the distance. So as we know that distance is equal to speed into time. So we know the speed of the ultrasonic sensor is, so the ultrasonic sound waves is 330 meters per second, and from this we would get the time. So now, but we know that the ultrasonic waves have traveled twice the distance. So we need to divide this by 2, and also the pulse-in command gives an output which is in microseconds. So we need to convert it into seconds. So we need to multiply a factor of 10 to the power minus 6. But as we know that we need to measure our distance in centimeter. So again, we need to multiply it by 10 to the power 2. So in overall, we need to divide by 2 and multiply it by 10 to the power minus 4. So to show the output, I am going to use serial dot println, and here multiplying 330 into 10 to the power minus 4 and dividing by 2, we get 0.0165, and then multiply with our time. Let us run the, and also see our reading. We will give a delay of 10 milliseconds. Let us run the code. Not able to get the error exactly. Oh, okay. So, I got it. So first, here we need to mention that which pins are our input pins or output pins. So here, the trigger pin is our output pin. So we need to specify that using pin mode command, and that is pin output. And then, as we know that we are taking the input from the echo pin, so we need to mention that it's an input pin. So now I'm getting the readings. So as you can see, the distance here is measuring it, the object is present at 89.7 centimeters, and here in the reading, as you can see, we are getting roughly around 85 centimeters. So this much error also occurs in our practical life. So this was about the ultrasonic sensor. So again, I have prepared a live demo for you all.
Hello, Nirmal.
Ah,
Uh, Please explain the code once again. A student is asking to explain it once again.
okay, okay, okay. So first, I have attached the ultrasonic sensor. As you can see, the VCC is attached to the positive ray here, and the ground is attached to the ground of the system. The trigger pin is attached to our 10th pin, and the echo pin is attached to 9th pin. You can connect it to any pin of any digital pin you want. So first, I have set up the serial monitor to get my output on the serial monitor. This is the command serial.begin 9600. So next, I have to specify that which pin is an output or input pin. So as we know that the trigger pin is an output pin because we are sending our data from Arduino to this sensor. So I have written pin mode 10 comma output, and then we know that the echo pin is sending how much for how much time duration it was high. So I have connected it to the 9 pin, so it's an input pin. So I have written here pin mode 9 comma input, and then we have to follow this. So first I'm going to keep my trigger pin low for 10 microseconds. So here, as you can see, I have kept the trigger pin was attached to the 10th pin. So I have kept it low. So for the command to use is digital write 10 comma low, and then I have given a delay of 10 microseconds using this command. So now I have to keep my trigger pin high for 10 microseconds and then make it low again. Okay. So here I have made it high. So digital write 10 comma high, and I have kept it high for 10 microseconds, and then I again make it low. So now I have to calculate the time duration for which my echo pin, which is connected to the 9 pin, is kept high. So the command used here is the pulse in command. So it has two inputs. So the first one is the pin number which we need to specify, and we also need to specify that whether that pin, so the time duration for which it was high or for which it was low. So we need to measure the time duration for which it was high, and it gives an output in microsecond. So I have saved it in this variable time, which has a data type of double. So now to measure the distance, we need speed and time because distance is equal to speed into time. And we know that the speed of ultrasonic waves is 330 meters per second. But the time here is in microseconds. Hence, we need to multiply it with 10 to the power minus 6. But also, as the waves have traveled twice the distance, hence we need to divide this by 2. So, and also one more factor we need to take in is that we are measuring our distance in centimeters and not in meters. So overall, we have to divide it by 2, then multiply it by 10 to the power minus 6, and again multiply it by 10 to the power 2. So I multiplied it with the constant 330, and I get this value. And I multiply it with time, and then I print it using this command, and then I have given a delay of 10 microseconds, 10 milliseconds. So I would run this code. So now, as you can see, the object is kept at 89.7 centimeters. But in our serial monitor, it's showing roughly around 85 or 86 centimeters. So this is the actual practical error which we get. So I hope that you have understood the code. So now I would show you a live demo of it. Here is the circuit which I have connected. This is an ultrasonic sensor. So I'm going to upload the code here. This is the serial number. So now I would keep my hand nearer, and as you can see that on the serial monitor, the value has been decreased and it shows roughly around 5 centimeters. And now I am moving my hand away from the ultrasonic sensor. So it shows around 10 or 11 centimeters. As you can see, this is how an ultrasonic sensor works. So to finally conclude the session, we are going to conceptualize a project which would help you get a deeper insight into how these sensors come together to produce a meaningful real life application. So we are going to conceptualize a radar bot. So basically, a radar bot is going to be a miniature version of the actual radar. So you know the radar used in airports and military to map the air. So to get an idea that which aeroplanes or fighter jets are present at what distance. So if any unauthorized vehicles come below a threshold distance, the radar alarms the user. So the aim of the project is that an ultrasonic sensor would be mounted on the servos and which would keep on rotating from 0 to 180 degrees and from 180 degrees to 0 back and forth. And if the distance falls below an threshold value, then the buzzer will alarm the user. So let me explain it to you in the Tinkercad. Here is the circuit which I have already set up. First, I'm going to explain to you the connection of the servo. So as you can see that this is for the ground and this is for the power, and I have connected the signal pin to the 7th pin here. And for the ultrasonic sensors, I have connected my trigger pin to the 13th pin and my echo pin to the 12th pin. And for the buzzer, one end is attached to the ground and the another signal wire is attached to the 8th pin. So now I'm going to explain to you how to write the code. So here I'm going to explain to you the code of each and every component. So first I'm going to explain to you how to write the code of the server. So here as you can see I have to include the library first, then I have to create an object, then I have created a variable cost or position, and in setup I have to write to which pin the signal pin is attached. So as you can see it's attached to the 7th pin here, and then in the loop, I want to rotate it from 0 to 180 degrees back and forth. So here in the for loop, I have written from 0 to 180 degrees an increment of the angle by 1 and using the command s dot write pos. Then I have given a delay of 50 milliseconds. And similarly, to rotate it from 180 degrees to 0, I have written it again the similar way as I have written this for loop and given a delay of 15 milliseconds. So now, using this much code, the servos will rotate from 0 to 180 degrees back and forth. So now, let us understand the code for the ultrasonic sensor. So here, I have defined that my trigger pin is attached to the 13th pin and the echo pin is attached to the 12th pin. So now, I have written this function which is used to find the distance and it would return a double value. So the code is the similar to one which I have explained to you previously. We have to keep our trigger pin low for 10 microseconds. Then we have to make it high for 10 microseconds and again make it low. And then we have to measure the time for which the echo pin was high and then multiply it with 0.0165 to get the distance and return this distance. So you can see that this function is called here, and I am storing it in the variable d, and then I'm printing this on our serial monitor. So now, if let's say our threshold distance is about 100 centimeters, if my d falls below 100 centimeters, then the buzzer should ring. So to ring the buzzer, this is the command which we have to use. So the command is tone. It takes three inputs. The first, we have to specify to which pin has been attached. As you can see, this is attached to the 8th pin. Next, we need to specify that at what frequency we need to ring this. We need to ring it at 2000 hertz and for how many milliseconds. So we need to ring it for 15 milliseconds. So similarly, I have done it here. So let us run the code. The serial monitor, as you can see, the distance is about 112 centimeters. So let us take below our threshold value to see what happens. As you can see, the buzzer starts to ring immediately. And if I make it greater than 100, then the buzzer stops. So this is how we can use different types of sensors to make a real life application. So I would like to conclude this session, and if you have any doubts, then you can ask in the chat box, or you can on your video and
Hello,
ask it.
Nirmal.
Uh, yeah,
Uh, Please explain the uh, tone again, tone part.
okay. So first, I would like to again explain what is the aim of the project. So our aim of the project is that the servo would rotate from 0 to 180 degrees and from 180 degrees back to 0, and the this ultrasonic sensor would be mounted on the servo and it would also rotate from 0 to 180 degrees. And if it detects any object which is below a threshold value, let's say 100 centimeter, then the buzzer will ring and alarm the user. So here I have first written. So first I have explained the code that we need to rotate the servo from 0 to 180 degrees back and forth using the servo library, and then attaching it to our the signal wire to the seventh pin, and then the two for loops to rotate it from 0 degrees to 180 degrees back and forth. Then I have explained the code about the ultrasonic sensor that we need to find the distance from the object. So it has so that for that I have written this function find distance, and I have copy pasted the exact code which I have explained to you earlier. And then I am returning the distance. So I am returning calling the function here, and storing it in variable D and then printing it on the serial monitor. So if the distance is less than 100, then we need to alarm the user by ringing this buzzer. So I have written the command for here. So the command we need to use is the tone command. So we need to specify three inputs. So the first input we need to specify is to which pin the buzzer is attached. As you can see, it's attached to the 8th pin here. Next, we need to specify that at what frequency do we want to ring this. We want to ring it at 2000 Hertz and for how many milliseconds. So we need to ring it for 15 after at each interval of 15 milliseconds. So let me run the code. As you can see, the distance is about 100. So the buzzer it's not ringing, and you can see the servo is rotating from 0 to 180 degrees. But in the Tinkercad, the ultrasonic sensor would not rotate. So you need to get an you need to imagine that this ultrasonic sensor is attached on the top of the servo, and it's also rotating with servo. So as you can see, the distance is around 119 centimeters, and on the screen it's showing roughly around 114 centimeters. So if I decrease the distance, then you can see the buzzer starts to ring. And as soon as I make the distance greater than 100 centimeter, then the buzzer stops to ring. So this was about radar bot. So if you have any more questions, then feel free to ask.
Hello.
Okay, so now I would hand over to my colleague Aniket who take the session forward.
Hello, am I audible?
Yes, Aniket, you are audible.
Uh, Hello, am I audible?
Yes, Aniket.
So hello, I'm Aniket Agarwal. Nice to meet you again. Hope you enjoyed this session and just we so yeah. Now it's time for hello, 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 hello. Am I audible?
Yes.
Sorry for the internet problem. Okay, so now taking this session forward. First, I would like to tell you about the assignments which we are having at the after the end of the session. So you will have to submit your assignment till Saturday night. For that, we will we will share a submission link in which you have to submit your assignment. So I will show how to submit your assignment and what are your assignments. So for that, start share screen. Just 1 second. Share screen. Okay. So we for submission of your assignment, we have given you 5 projects. We will share the link of this doc. You have to choose any of the projects and you have to simulate your project. You have to create a new project in Tinkercad, and then you have to create just as you create a project, you have to create a circuit, and then just you have to create some projects like you do, and then finally you have to go back to your dashboard. So you have to go back to your dashboard after making the project in Tinkercad, and then you have to here in properties you have to do your project public, and then you have to share this link with us. So this link will help us to see your project and to simulate your project whether it is correct, or whether we have some improvements for you. We will share the comments for you right here. So share this link in the submission form we will send, and also write the project number you are choosing in this doc. We will share this doc and the submission link just after sometime after the session. Okay, so this is all about the assignment. You have to submit it till Sunday night. We will share all this information in the mail we will send after the session. For now, if you have any question, we will have a Q&A session. So you can unmute your mic and ask, or you may type in the chat box. You may also unmute your mic and ask your doubts. Okay, so if there are no further doubts, I would like if there are no further doubts, I would like to have start the quiz. So yeah, there is a quiz for today's session also. Okay, so I am going to start the quiz. So just go again to joinmyquiz.com and enter this code. I will share the link to. So I have shared the link in the chat box for the quiz. Again, join with your original name, as it will be required for the attendance purpose. So, is anyone having trouble in joining the quiz, or everyone has joined? Okay, so I guess everyone has joined now. Uh, okay, so now I'm going to start the quiz, as I think every one of you has joined. Okay, so let's start. I guess uh, we all have completed the. I guess we all have completed the quiz. So I'm going to end it now. Uh, okay, let's end the piece. Uh, yeah, so we have a feedback form. So please fill that form. If please fill that feedback form. We have given that in the chat box. So now, if you have any doubts regarding the question in the quiz or any doubt in general for today's session or previous session or any resources, you can ask that by unmuting your mic. Yes, Malhar. Yes, you can ask your doubt. To raise your hand.
हाँ वो गलती से होगा सॉरी.
Okay, okay. If you have any doubt, you can ask that in the chat box, or you can unmute your mic and ask that. Also, if you are if you don't get how to submit your assignments in the Tinkercad, how to create your project in the Tinkercad and submit the link, you can ask that, or you can ask that also in the Telegram group if you are not able to submit. What is PIR sensor? So PIR sensor is basically a sensor which detects the motion. So if any radiation around it changes, if any changes occurred in its surrounding and the radiation due to the motion, it gives an output of high. Okay, I think Rahul has asked the question if trigger wave and reflected wave are colliding. So, as trigger wave just goes for 10 milliseconds, so its duration when trigger wave goes is just 10 milliseconds. So, where it becomes the reflected wave when it comes back. So, the two wave are not the same. Means, if you have any query in particular, what you are uh, just explain the whole situation so I can get your question. Okay, yeah, it can be increased, but in general, it we use 10 millisecond as as it is a common convention to use 10 millisecond. Uh, this is a this is done for best output means decreasing the error in your code. If the object is too near. Yeah, so ultrasonic gives some error in that case. So basically, the sensor does not get 100% accuracy, and with various distance, the errors increases or means the error changes with various distances. So, but yeah, you get approximate distance most the time. Also, it has a limit up to 200 centimeter, so it can't get the so it can't get more than that distance. Right? Yes. Can we not initialize? Okay, so when you write servo s, you don't need to initialize it there. You have to initialize it at the in the void setup function. You have to write s dot attach. There you initialize the s servo s. You you can't initialize it there as servo s is a class. It's not an int. It's another a variable of a class. Okay, so serial dot begins in 9600. As we explained in the previous session, it's just a baud rate which can vary which can vary. You can choose your baud rate accordingly. You have different options in the serial monitor. So it's just a rate at which your serial communication takes place with serial monitor. If any of your doubts is still not cleared, you can ask by unmuting your mic too. No, means like if you means it has an error at all distance. So if you decrease the distance of the object too much, the error might be 100% too. So like if you place the object for like 2 centimeter like this, then you may get the error like you may get the distance from 1 to 4 3 or 1 to 4. So the distance may not be useful in that case. So it's generally preferred to use at an approximate from some not for that much a small distance, from some moderate distance to up to 100 or 110 centimeter. It's best to use the ultrasonic in that case.
So the different models of the servo, like it depends on the torque. Like if you buy expensive servos, then they provide a higher torque, and also they have a special capabilities to rotate from 0 to 360 degrees.
No, ultrasonic is preferred to use in a straight line. Means it does not work means if you have to work on an angle, then you can rotate it with servo, like we showed in the radar bot simulation. You can try it out if you have ultrasonic and servo motors at your home. So, do you guys have any more doubts? We have put some feedback link. So please fill that form too before leaving. Increase. So the speed of servo cannot be changed by your code. Means the speed can only be changed by higher voltages or something like that. Means so the Arduino provides a constant voltage of around 5 voltage. So you cannot change your speed by your code. uh, please share your you have written your code in the Tinkercad, na? So please share your code with us. You can send your link here so we can see what's your code and what's the or anything. Everyone, can you please so that we can have a photo of this session? Please turn on your camera.